Okay, let's do number 5. These problems were made specifically for the AP test this year, so please pay attention to it, practice them, look through them, understand them, ask questions about them. I have several students that have asked questions about specific parts of it, so keep them coming. All right, number 5 is a particle problem. A particle moves along the x-axis, and the position is a piecewise function. So from 0 to 1, it's going to be this ln function, and from 1 greater than 1, it's going to be a cosine function. So we have the position, and a is said to find the velocity. That's the derivative. So a is just the derivative of this piecewise function. So here we go. V of t equals, the derivative of a natural log is 1 over everything. So 1 over kt times the derivative of the inside, which is k, and that's it. So there's our first part. Our second part is this t cosine right here. So it's going to be like this. So first times derivative of the second, which is cosine, so negative sine 4 pi t, times the derivative of the inside, which is going to be 4 pi. All right, so first times derivative of the second plus the second, so cosine 4 pi t, times the derivative of the first, which is 1. All right, we're done with part A. Don't have to simplify anything yet. We will simplify it in the next step, but that's good enough for part A. Part B asks for the acceleration. Now, before I do the acceleration, I gotta clean up the velocity, otherwise it's gonna be a little bit too much. So let's clean up the velocity function first. So I noticed the k's are gonna cancel and it's just 1 over t. And then this one right here, let's put this all together. So negative 4 pi t sine 4 pi t. And then I have this plus cosine 4 pi t. All right, so now it's kind of clean. Now let's take the derivative again to get the acceleration this time. So a of t equals, and the derivative of this, basically it's t to the negative 1, right? So bring down the power, negative 1, and then times t to the negative 2. And that's good enough for me right there. That equals negative 1 over t squared. Just throwing that out there. The negative can be out front. All right, so we have a product rule here as well. So first times the derivative of the second, 4 pi t times 4 pi, plus the second, sine 4 pi t, times the derivative of the first, negative 4 pi. Good. So first times derivative of the second, plus the second times derivative of the first. And then I have this derivative of cosine, that's going to be negative sine 4 pi t. It stays the same inside. Now the derivative of the inside is 4 pi. All right, I like both those answers as my part A and part B. Let's see what part C has to say. Part C is determine if this particle is speeding up or slowing down at 3/2. So we have to find the velocity at 3/2 and the acceleration at 3/2. And if they have the same signs, then they're going to be speeding up. If they have opposite signs, they're going to be slowing down. So I don't really necessarily need to know the actual numbers. I just need to know if it's greater than or less than 0. So let's test it out. Part C, let's do the velocity. Now, I'm not worried about the natural log one because 3/2 is greater than 1. So we're just going to focus on the cosine thing. So V of t, well, actually, I want to do V of 3/2, right? 3/2 equals negative 4 pi 3/2 times sine of 3 times 4 is 12 divided by 2 is 6 pi. Wait a minute. Sine of any pi is going to be 0. So 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, all those on the unit circle, that goes away to 0 anyway. So plus the cosine of 4 pi 3/2, right? That's going to be 6 pi again. So that equals cosine of 6 pi and 6 pi. So 0 is 1, 1 pi is -1, and then 1, -1, 1, -1. So any 2 pi, 4 pi, and 6 pi are going to be +1. So this is greater than 0. Positive. Okay, let's try the acceleration of 3 over 2. I remember that sine of 6 pi is 0, so I'm not going to worry about this section or this section because that's going to be 0. Let's see here. This is going to be -4 pi 3 over 2 times, I remember cosine of this is +1. So I'm just going to times it by 1, 4 pi. Plus that's going to be 0, and minus that's going to be 0, so I don't need to worry about that. This is a negative number, so negative times all these positives, and the negative number, it is less than 0. So opposite signs means slowing down. Good enough for me. Let's go on to part D here. I need a piece of... Right, part D is to write but don't solve an equation using a single trig function for the particle at rest. So this is about the particle at rest. That means v of t has to equal 0. All right, so if I look really quick at v of t, this is the simplified version. So v of t is 1 over t at that point. Now, wait a minute here. T can't be 0, and 1 over is never 0. So that's never 0. From 0 to 1 is never 0, so I don't have to worry about that one. I have to worry about this bottom one. So -4 pi t sine 4 pi t plus cosine 4 pi t. All right, so let's write that as one trig function. Kind of a weird question, right? But it's basically, do you know that the particle at rest means velocity equals 0? Do you know that? Here's the equation for it. I'm going to add this onto the left-hand side. So now I have a positive 4 pi t sine 4 pi t equals cosine 4 pi t. And to get one trigonometric function, I got to put these two together. So if I divide by sine 4 pi t, I can move those together as a cotangent. So 4 pi t equals cotangent of 4 pi t. And that's, now you could have done it a lot of different ways, right? You could have divided this cosine over here to make tangent. You could do different things, right? So don't worry if you get a different answer. If you see a different answer out there, it's pretty good. How about part E to finish things up? Part E. So what is the value of k such that the velocity of the particle is continuous? So continuous means, you have to go to the definition of it. Continuous means that from the left and from the right, they meet, right? And that point is there, right? So it's not some jump or whatever, but the 2 points meet at the same point. So from the left, from the right, and they meet there together. So we have to test that out and set them equal to each other. So that means ln kt has to equal t cosine 4 pi t, right? So when at t equals 1. So those have to be equal to each other. So when are they equal to each other? So ln k times 1 times cosine of 4 pi, and that's 1 again. So when is this true? When is L natural log of k equal to 1? Ln of e equals 1. So k has to equal e. That's got to happen, right? So now that I know that k has to equal e, I just state that from the limit as the velocity of the velocity curve, v of t, as t approaches 1, right? So the velocity equals the limit as v t approaches 1. So let's see here, from the left and from the right, they equal each other when k equals e. So this is stating the definition right there of continuity, that the limits meet each other, and that only happens when k equals e, and we have our final answer there. So if there's any questions, keep them coming. Good luck.